Dear students, in today's class, I will continue with capacitance grading for the same safety factor of dielectric material. First, we'll take for the same safety factor. Let us first understand what is the meaning of safety factor in case of insulating materials. In case of insulators, safety factor is defined as the ratio of rated electric stress to permissible maximum electric stress of a cable. Let safety factor of all the three insulating materials used in cable is F. The value of epsilon 1 will be such that the electric stress, that is dielectric stress, at the surface of conductor is equal to E1 by F. That is the electric stress at the surface of conductor is Q upon 2 pi epsilon 1 R, and that must be equal to what? E1 upon F. Let us call this as equation 1. Similarly, value of epsilon 2 will be such that Q upon 2 pi epsilon 2 R1 is equal to E2 by F. Let us call this as equation 2. And epsilon 3 value will be such that Q upon 2 pi epsilon 3 R2 is equal to E3 upon F, because at the outer surface of second insulating material, maximum stress appears, and that is equal to E3. Now let us call this as equation 3. From equations 1 to 3 we can write Q equal to two pi epsilon 3 R2 into E3 by F, that is equal to 2 pi epsilon 2 R1 into E2 by F, that is equal to 2 pi epsilon 1 R into E1 by F. Simplifying, we get epsilon 3 R2 into E3 is equal to epsilon 2 R1 into E2, that is equal to epsilon 1 R into E1. Now let us call this as equation 4 and this as equation 5 for our future reference. Since means here from figure we know that, right? R is less than R1 and R1 is less than R2. In these equalities, epsilon 1 E1 is greater than epsilon 2 E2 and epsilon 2 E2 is greater than epsilon 3 E3. Let us call this as equation 6. From equation 6 we can say that insulating material highest product of permittivity and dielectric strength is placed near the conductor. The operating voltage of cable can be obtained as V is equal to positive integral of dielectric strength from integration of E1 with respect to dx from R to R1. Here positive sign is taken because integration limits are from R to R1 plus R1 to R2 E2 dx plus R2 to capital R E3 dx. If we substitute for these values, we get here. You should know what are E1, E2 and E3. E1, E2 and E3 are the dielectric strengths of insulating material 1, 2 and 3 respectively. What are their units? Their units are volts per centimeter. So we are multiplying here by dx. What is x? X is in centimeter. It is the distance. So when you multiply volts per centimeter or kilovolts per centimeter with centimeter, you will be getting volts, and volt is the unit of voltage. So if you add all the integrations here having unit of volt, you will be getting operating voltage. So substituting and simplifying, we get substituting for E1, E2 and E3 and simplifying, we get Q by 2 pi inside the bracket 1 over epsilon 1 ln of R1 by R plus 1 by epsilon 2 ln of R2 by R1 plus 1 by epsilon 3 ln of capital R by R2. Bracket complete. Now let us call this as equation 7. Next we'll take the other criteria, that is with the same maximum stress. If all the three materials are subjected to the same maximum stress, the stresses at R, R1 and R2 will be same. Now we can refer to this figure for understanding. Again, same cross section of the cable is considered with radius of conductor R and radii of insulating materials as R1, R2 and capital R. Permittivities as epsilon 1, epsilon 2 and epsilon 3 in their increasing order from conductor to the sheath of cable. Here you can see that the maximum electric stress at the surface of conductor is equal to the maximum electric stress at the surface of insulator 1, insulator 2 and insulator 3. The relationships can be written as Emax equal to Q upon 2 pi epsilon 1 r, that is equal to Q upon 2 pi epsilon 2 r1, that is equal to Q upon 2 pi epsilon 3 r2. From this equality we can obtain epsilon 1 r equal to epsilon 2 r1 equal to epsilon 3 r2. Since r is smaller than r1 and r1 is smaller than r2, we can write using this equality now. Epsilon 1 greater than epsilon 2, epsilon 2 greater than epsilon 3. Thus, for the same maximum stress the material having the highest permittivity should be placed near to the conductor. And next highest is placed after that, and so on. In this case, the operating voltage of cable may be obtained as V equal to E1 max into R into ln of R1 by R plus E2 max into R1 into ln of R2 by R1 plus E3 max into R2 into ln of R by R2. Since we have considered E1 max equal to E2 max equal to E3 max, V may be calculated as E max into the bracket R into ln of R1 by R plus R1 into ln of R2 by R1 plus R2 into ln of capital R by R2. Now let us call the equation on last page as equation number 8 and the last equation here as equation number 9. Dear students, I will stop the class here and continue in next class. Thank you.